Hello everyone. Today I along with my group members are going to present you on our project that is Smart Overload Detection and Prevention System for Road and Structural Safety. Now here we have the abstract part. Roads and structural safety plays a vital role. The government spends and invests heavily in the construction of roads and bridges in our country. But one of the major challenges is to maintain the roads and bridges in good conditions for the vehicles that exceed the design load. These vehicles are responsible for the degradations of the roads and bridges. In some cases, the bridges even collapse, leading to substantial loss of life and money. So we have conceptualized a smart system that will be actively detect the vehicle weight which exceeds the design load of the roads and bridges. Also, I would like to mention you that since there is a worldwide outbreak of COVID-19 resulting in lockdown situation, the work has suffered a great deal like everybody else. So our proposed model is shown based on the CAD model. The fabricated process described will be proposed or possible processes. Now moving on to the next, here we have the introduction part. Due to the adverse effect of the overweight vehicles, frequent measures are taken by the government for repairing the structural components, which requires heavy investment. In some severe cases, the bridges even collapse, leading to substantial loss of life and money, as well as paralyzing the commuter of the connecting places. Though there exists ways, means, and laws for checking the loading of a vehicle, it is not that effective. So our design will be an asset for government, as the current system which are available to prevent the overweight vehicles are not smart. As a result, we have come up with a unique road structure along with a road smart vehicle overload detection system, which is designed to effectively manage traffic congestion related problems, which will help to prevent degradation of road structure components due to the excess weight of the vehicles. Now, moving on to the next year, we have the motivation of the project. Our project will be a government backed as it is capital intensive project and will act as an asset to the government to reduce the maintenance cost of roads and bridges. And it will also give a value to the smart city concept proposed by the government of India. The reduction of maintenance costs by the use of modern techniques is one of the way to save the economy. Now moving on, here we have the project overview. Our system will detect the overweight vehicles by using weight sensors. The weight sensors will detect the weight of the vehicle and it will send the signal to the Raspberry Pi. Then the Raspberry Pi will check whether the vehicle is overloaded or not. If the vehicle is overloaded, the auto barricade system will be activated and it will prevent the overload vehicle to pass over the bridge. And our smart road design will help the overload vehicle to easily turn and return without any traffic congestion. Thank you.
Hello everyone, I'm Masud Hussain from Mechanical 8. My roll number is DC2015BTE0168. As you know that our project title is Smart Overweight Detection and Prevention Systems for the road and structural safety. So for this project we have gone through lots of literature papers. I am going to explain today some of the most important literature papers where from we get the concept of our project. And here is the first one, VIM for the detection of overweighted vehicles. This allows detection of the overweighted trucks or vans which are also responsible for the road damage and the road accidents. So this document describes solution which is an combination of video recognition at the weight in motion solution which allows the detection of the overweighted vehicles. So how to detect the overweighted vehicles, we get the idea from this paper. And second one is the this one is most important, and we have collected the idea of the automatic barricade system from this, the Lufthansa NIPA development of the traffic control system by using microcontroller based barricade system. Actually they used some microcontroller automatic systems in their barricades to control the traffic, and this one is connected to their actual the programmable microcontroller, and make it autonomous, and this traffic barricades use in autonomous way. So we get the idea of our automatic barricade system from this one. And third one is this one. Here actually from this paper we get the idea of electrical energy generation from the piezo sensor and for the unwanted ground vibrations. So this paper is Raghu Chandra Grimela. They published in 2015. Actually an approach to generate the electricity from the vibration, and the generation of electricity by the piezoelectric sensors, we get the idea from these papers.
Hello everyone, my name is Vishal Kakati and I'll be speaking about the objective of our project. So the first is to prevent the degradation of the roads and the structural components due to the excess weight of the vehicles. So the structural components gets broken down every year or most frequently due to the excess loads of the vehicles passing over them. The next is to implement an alarm system to warn the overweight vehicles. The third is to implement an auto barricade system which will prevent the overload vehicles to pass by. The fourth is to implement an auxiliary power source that will generate energy from the vehicles passing using a piezoelectric sensors and a solar energy. Next, we have the methodology. In this project, a smart overload detection system is being designed to prevent the degradation of the roads and the structural components due to the excess weight of the vehicles. The smart system will be consisting of a Raspberry Pi, which will be programmed using a Python language to calculate the load of the vehicles. We are using the Python language here because the Python is the only language that the Raspberry Pi understands. And also there will be attachments to the Raspberry Pi, like the load cell to measure the weight and the sensors to convert analog to digital signals like the HX711. There will be also attachment for the barricade system like the motor driver L293D, which will be connected to the Raspberry Pi to control the barricade system for opening and closing. So next, if the vehicle passes over the plate, the piezoelectric sensors will generate the electricity, and the load cell and the HX711 will detect the weight, and they will send the digital signal to the Raspberry Pi, and the Raspberry Pi receives it. And if the vehicle is overweight, the Raspberry Pi transmits the signal, and an alarm and a barricade system gets activated. And the vehicle returns back with ease by the special road structure that is designed in our project. If the vehicle is not overweight, the vehicle passes by with ease. So these are the different machining operations undertaken. Number one is the cutting. In the cutting operations, a cutting tool is used to remove some materials from the workpiece, utilizing a shear deformation. Next, we have the drilling. Drilling is nothing but a cutting process that uses a drill bit to cut a hole of circular cross section in solid materials. Next, we have the grinding operations, which is an aggressive form of machining. Thank you.
Hello everyone, I am Bonjat Khaman and I will discuss about the proposed model and road structure along with an example of a bridge construction site. So first to begin with the model design. This is the CATIA model of our project. So these are load cells. We have brought the equipments and did a connection, but since there is no workshop available, we are unable to do the fabrication. When the vehicle arrives, the load cell will take the reading and send it to the A6711, and it will transmit the data to the Raspberry Pi in this box, and there is a motor which will run the belt drive and then the barricade system. This is the design of the proposed road structure for the installation of our system. So here is the road divider. As the vehicle approaches from here, it will be stopped before the barricade and the load cell will detect the load of the vehicle. If the load of the vehicle is within the limit, the barricade will open and the vehicle shall pass, and if not, then the vehicle have to take a U-turn and return to its earlier path. Here at bridge construction site, this is the alternative bridge for the paddlers and the two-wheelers, but as the water level rising up, they have to choose a different route. The wooden bridge was made for the lightweight vehicles, but has to be reconstructed every year due to heavy soil carrying trucks. Last year, they've decided to make a concrete bridge, but due to COVID-19, no work has been done. Our project idea would be very much applicable in this scenario to protect the new made bridge, and the area here would be very much suitable as per the proposed road structure.
Hello everyone, my name is Deepsai Talukdar. My ID is DC 2016 BTE 0244. Now I am going to explain about the working mechanism of our project. So at first a proper road structure is laid down as shown in the figure along with its various components indicated by arrow signs. The road structure should be laid down in such a way so that it turns out to be of utmost convenience to the people and does not cause any hindrance from the point of view of traffic. The weight sensor plate consists of load cells along with HX711 load amplifier module, a L293D motor along with a Raspberry Pi module, all inscribed in the circuit box. So whenever any vehicle gets over the weight sensor plate, the load cell senses the pressure of the vehicle on the floor near the gate and supplies an analog voltage to HX711 load amplifier module. The electrical signals generated by load cell is of very few millivolts. As such, the HX711 load amplifier module amplifies this low electric output of load cell and after amplification converts it into digital form. Upon amplification, the digitally converted value is then fed to the Raspberry Pi module to derive the weight. The Raspberry Pi calculates the weight by using a Python programming language. After that, it compares the deduced weight of the vehicle along with the reference weight, that is, the weight which the bridge can bear. If the weight detected by Raspberry Pi comes out to be more than the reference weight, that is, if overweight is detected, then the barricade system gets activated and it will restrict the vehicle from passing by. In such a scenario, the vehicle will have to take an alternate way through the road divider. However, if no overweight is detected, then the vehicle will be allowed to have a smooth passage as usual. Further, the weight sensor plate is equipped along with electrical energy generating sensor, that is piezoelectric sensors. Thus, in this way, the overweight or overloading of vehicles can be detected and prevented by using a smart system so that it does not cause any damage to the roads and structural component of our country and maintains structural safety. Thank you.
Hello everyone, my name is Deva Pradeep Sharma and now I'm going to discuss about the fabrication phase and about the program required for a smart system. So after finalizing the design, we plan to build the proof of concept prototype. For this, we have selected load cell and HX711 module for weight detection, Raspberry Pi to control the system, L293D module and DC motor to control the auto barricade system, and Python programming to run the system. The components for undertaking this fabrication, along with the criteria for the selection of raw materials, are shown in the slide. Material selection is an essential aspect of the engineering processes of both products and production system, and often crucial for the success of the resulting products. The following are the types of material properties. First one is the mechanical properties, the wear of materials, corrosion, manufacturing cost, availability of materials, space consideration, and cost. A number of components have been used for the successful completion of the proposed proof of concept prototype. Here, some of the components of our prototype are shown. First is the frame, then the Raspberry Pi, load cell, HX711 module, DC motor, L293D module. The various stages involved for the fabrication of the proof of concept prototype is shown in this slide. First step is the construction of frame. For the frame, square channel pipe of mild steel is used as it is heavy and will be able to sustain under different conditions. The necessary markings were done on the channel pipe considering the dimensions. Various operations involved are cutting, drilling, grinding, and arc welding. Next step is the placing all the equipments in frame. All the equipments were placed according to our design. The load cells, sensors, and piezoelectric sensors are placed below the aluminum metal sheet. Beside the metal sheet, a motor and a box type structure are placed that will contain the Raspberry Pi, HX711 module, and L293D module. The barricade system is placed next to the motor and they are linked by a belt and pair of pulleys. Next step is connecting all the equipment with their respective order. The load cell is connected with the HX711 module by connecting red, black, white and green wire of the load cell with E plus, E minus, A plus wire of HX711 module. The DC motor is connected to the output port, that is M1 and M2 of the L293D module. The Raspberry Pi contains a row of 40 pins known as GPIO pins, that is general purpose input-output, which helps in receiving and transmitting signal to various devices. To make the connection proper and error-free, we have extended Raspberry Pi's GPIO connection ports to a breadboard with the help of 40-pin GPIO extension board and 40-pin GPIO gray cable. The wires from the port, ground, DT, SCK, and supply of HX711 module is connected to ground, GPIO ports 27, GPIO port 17, and 5-volt port of the Raspberry Pi. Similarly, the wires from the 5-volt ground, input 1 and input 2 port of the L293D module are connected to 5-volt ground, GPIO port 12, GPIO port 16 of the Raspberry Pi. After connecting all the equipments, a Python program will be required to successfully run the smart system, which is shown in the coming slides. In real-life application, if government finds this project suitable, then it will implement in collaboration. For that, some of the potential equipments which can be implemented are shown. For weight detection purpose, WIM system can be implemented, that is weighing motion sensors. And for barricade system, AGH7 horizontal automatic barrier can also be implemented. Next steps to be followed are constructing the frame with proper dimensions and machining operations, placing all the equipments in the frame in proper order, combining more than one load cell for weight detection, which could not be completed due to the pandemic situation of COVID-19. Next part is programming the smart system. To make our system smart, to detect the weight failure from the HX711 module and load cell, and to run the DC motor accordingly with the help of L293D module, we have to incorporate logic and smartness to the system. For this, we are using a Raspberry Pi microcontroller which has the capability to control all the equipment simultaneously via its GPIO port. To work with a Raspberry Pi, we need to program the system according to our needs. For enabling this capacity to the Raspberry Pi, we need to program the system. For programming purpose, we are using Python language since Python syntax is very clean. It emphasizes readability and uses standard English word. The details of our smart system program is shown in this slide. So first of all, we have included library for the GPIO pins of the Raspberry Pi and also defined the pins for HX711 module and DC motor. Here, as you can see that the port DT and SCK of the HX711 module is defined to the GPIO port 27 and 17 of the Raspberry Pi. Similarly, M1 and M2 port of the L293D module is defined to 12 and 16 GPIO port of the Raspberry Pi. Here, we are referring to the pins by the Broadcom SoC channel number. Next, we have given a library for reading the data from the HX711 module. Here, in this slide, HX711 module data comparison is shown with reference weight for controlling the barricade. A number of trial runs have been conducted after uploading the program to check for the working of the system. Though we could not complete all the fabrication processes due to pandemic, we did some of them like connecting a circuit, writing the program. In our trial runs, we have used some reference weights just to see whether the system works or not, and we found that it is working fine. Thus, we can say that in a complete proof of concept prototype, it shall work.
Hello everyone, my name is Deepsai Talukdar. My ID is DC 2016 BTE0244. I am going to explain the conclusion part of our project along with the future scope and further possible discussions. We all know that in a developing country like India with such a huge population, advanced roads, bridges and other structural components play a very significant role in the overall development of the country and also to boost its economy. But every now and then it is observed that due to negligence of the people and the government, the structural components of our country suffer substantial damages, thereby causing a great threat of life and property to all the people. Although the government takes initiatives every year for the repairment of these bridges, but it requires huge investments. Also, it means nothing but just a mere wastage of public money in repairing the same thing over and over again. So, in order to come up with a permanent solution to this, we have designed a smart system which can detect the overloaded vehicles and prevent them from passing over by using various sensors and advanced mechanical and electronic tools. A smart overload detection and prevention system is designed and fabricated using the above mentioned tools for roads and structural safety of the bridges. This system will detect the weight of any vehicle as soon as it gets over the weight sensing plate near the barricade and will only allow those vehicles to pass by which are not overweight. In this way, the bridges will not be hampered and also there will be no risk of life and goods. This will in turn save huge amounts of government funding which are wasted every year for the repairment of these bridges. Thus, this project will not only be friendly from the economic point of view but also from the point of view of life risk. Future scope. Some of the components which are observed to be implemented on the proposed model are as follows. Like some of the materials which we have used in our project may be altered with some other materials which are cost friendly, thereby increasing the effectivity and overall productivity of the project. For example, we can use the Arduino module in place of the Raspberry Pi module as Arduino is less costlier than Raspberry Pi. The proposed road structure design may be varied or upgraded depending upon the convenience of the people so that it results in minimum traffic congestion as possible. As it is a government-based project, so any vehicle violating the rules of traffic for overloading may attract a penalty under the sections 194.1, 194.1a and 194a for violation of traffic rule as per the Motor Vehicles Amendment Act 2019. The FASTag reader may be implemented for carrying out the fine system as it employs RFID technology which can collect fine electronically, thus making it a cashless payment. By doing so, it will collect fine automatically without stopping the vehicle, thereby not causing any queuing of vehicles and hence will make a hassle-free trip. Last but not the least, an obstacle detection system can be implemented on the barricade so that it does not fall on any other vehicle when overweight of any particular vehicle is detected. Thank you.